In this video, I want to show you some, probably the grid is used for Boolean operators in computers. It's for managing flags. A flag is a bit that indicates whether something is enabled or not. So for example, imagine that we have 4 LEDs and we need to track which LED is on and which LED is off. So for example, imagine that we have this LED enabled, this LED enabled, and the other two are off. We could represent that using binary numbers. We could use a 0 when the LED is off and a 1 when the LED is on. So 0, 1, 1, 0. This will keep track of the current state of the LEDs. So how do we manage this number? For example, imagine that we want to turn this LED on. We need to put a 1 here. So in this case, we use Boolean operators. To put a 1 here, we can use the OR operator. So for example, if we take this number and we OR this number with this, the OR table will be 1 if either the first or the second number is a 1. In Boolean operators, we do it bit by bit. So in this case, this bit will be a 0, this bit will be a 1 because it was a 1 before, this bit will be a 1, and this bit will be a 1. So we have changed this from 0 to 1. So if we use the OR operator with a 1 in the bits that we want to turn on, we will be turning this LED on. What do we do if we want to turn a flag off? So in this case, we will use another Boolean operator. In this case, we can use the AND operator. The AND operator, the table of an AND operator, it will be 1 only if both values are 1. So if we AND this number with 1, 1, 0, 1, we are going to turn off this LED, and we calculate the result of the operations. This will be a 0 because we had a 0 here. We will have a 1 here. We will have a 0 here. We are changing this value, and we will have a 0 here. So in this case, we put a 0 in the flag that we want to turn off. This is the use for binary operation. We also will want to invert the state of the LEDs. So for example, imagine that we want to turn off this one. Okay, let me erase this. And turn on the other. This is the opposite. Remember that we had this on, this off, and this off. We want to invert the position. So we can use the NOT operator. The NOT simply inverts the value of the flag. You don't need another number here. So a 0 will become a 1 will become a 0, and so on. So in this case, using the NOT operator, we can invert the flags. And maybe we could invert, but only a single flag. Sorry. If we could, for example, invert this line, if we don't know if it's on or it's off and we want to invert the value, we can use the XOR. The XOR is like a NOT, but for individual bits. So if we put a 0 here, 1 here, 0 here, and 0 here, we put a 1 in the bit, in the flag that we want to invert. The XOR will be 1 only if one of the numbers is a 1. So in this case, this will result in a 0. This will result in a 0 because they are both 1s. So in the XOR is only one of the numbers, 1. In this case, it will be a 1. In this case, it will be a 0. So it keeps the state of all the bits except of those where we put a 1. So this is more or less the use of Boolean operators. I wanted you to have a grasp of the utility of for that. And if you, they are very simple to apply, but it's good to have an understanding of why they are used.